Hello, welcome back. This is question 2.2. It piggybacks on 2.1 and says, is Paul tall? So we keep the mean and the standard deviation from the last problem. And now they say, can you find Paul's z-score if you know he is, so I'll use a different color. We know he is right here, 179. So we're saying to ourselves, wow, that's pretty tall. He's taller than normal. And they want a z-score. So I'm just gonna go straight to the z, a over s. His actual height we know is 179. We would predict any 15-year-old boy to be 170. And we know again from the last problem that the standard deviation is 7.5. So crunch in the numbers here. We get the z-score has to be 9 divided by 7.5. And I get 1.2. Then it says something very specific here. It says explain. So what does that mean? Well, for one, it means he's tall. It means he's taller than average, but specifically it means Paul is 1.2 standard deviations above the mean. So this tells us that he is taller than the average person because the z-score is a positive number. Okay, let's press on. So that was 2.2a, and this would be 2.2b. If we're looking at our next question, it says, Paul's height actually puts him in the 85th percentile, which basically tells us the area under the curve to the left of his height is 85% of the people. What does this mean for somebody who's never taken a stats class? So they're really saying, explain it to me. Well, Paul is taller than 85% of other 15-year-old males. So that's really all it means. He's taller than 85% of his peers that are the same age. Okay. Now the question jumps to 2.4, so let's do it. 2.4a. So they give us a data set. They say a group of Australian students were asked to estimate the width of a classroom. So I'm saying, okay, well, how wide is my classroom? These kids in Australia, they're like, how wide is it? And so this is just getting to how good are they at guessing. And they gave us a little dot plot and summary below. So again, though, if this is too difficult for you to read, you can look in your book. And again, it's at the end of chapter 2 in your textbook. Okay, so let's assume we can read this question. It says, suppose we converted each student's guess from meters. So let me look here. It looks like there's some numbers. 43.7 is the mean, right? So we see from the problem, that's the mean. Median, if you squint really well, you can see should say the number 42. The standard deviation is 12.5. Okay, and notice that all of this data we're supposed to assume is in feet. So it seems as if most students think, or a typical student thinks that the room's about 40 feet-ish wide. So let's say that's my guess. If my guess was 40 feet, keeping our round numbers, they say they want us to convert it. So to convert this, I have to put 3.28 feet, and this is right out of the problem here. They give us the conversion factor, 3.28 feet, and convert this into 1 meter. Okay, so notice I'm dividing. That's really important here. So when I take my guess, 40, and I just made this number up, but when I divide it by 0.28, I get 12.195 meters. Okay, So notice that my guess of 40 would now be a different number, and it's still the same guess, it's just showing it in meters rather than feet. When I divide, this is a big deal because we've said before with our heights or when we're converting units that spread doesn't, measures of spread doesn't change when I add or subtract, but does when I multiply or divide. Now you can spell out those words, but I'm just kind of using the symbols. So I'll say that again. Spread doesn't change, we learned in class, when we add or subtract, but it does change when we multiply or divide. So obviously my guess changes when I divide. It changed by me dividing. But we notice that the spread doesn't. Any type of measures of spread don't change. So the question says, when I change from feet to meters, how does the shape affect? Well, I don't think it changes at all. I could literally, now a typical score, I could actually cross that out. And instead of the number 42 for the median or 43 for the mean, I could literally just replace that number. But unfortunately, the spread outedness, since I'm not just adding or subtracting, I'm actually dividing, the spread outedness is also going to divide. So the shape itself will be the same, but it'll look squishier. So if I kind of just approximated the shape, you know, maybe something like this, right? Something, we see a big bump over here, a couple little bumps. So maybe that somebody guessed really crazy high big number. If that's my shape before and then after, because spread does change when I multiply and divide, now it's going to be squisher. So, but the shape itself will probably be the same. It'll just be a little narrower. Okay. So before I divide, this is what it would look like. After I divide, this is what it would look like. So to answer that question, how does the shape change? It looks like before and after, it's skewed to the right. So before and after, it's skewed to the right. That didn't change. But since spread changed, the shape is more, right, the shape is narrower, I guess you would say. Okay, so now let's get to the other questions. It says, and I'm going to set this up kind of like a table, just it says, so mu, or the mean, before, and then I need to know it after. Okay. I need to know the median before and after. I need to know the standard deviation before and after. And the IQR before and after. Now let's take a look. The mean before, again, we said was 43.70. So if we convert that by dividing it by 3.28, 3.70, which is divide by 3.28, meters. My median is 42, so that gets divided by 3.28 because it was in feet and now it's in meters. The standard deviation was 12.5 feet. And normally this standard deviation is a measure of spread. Normally those don't change when I add or subtract, but they do change when I multiply or divide. So I am going to divide by 3.28. Okay, and the interquartile range is also a measure of spread. So I have to go back to my sheet and actually calculate this. So the IQR would be quarter 3 minus quarter 1, and that would be 48 minus 35.5. So that also would be 12.5. And 12.5 divided by 3.28 is 3.81. So now I've got all my measurements, and now they like me to quantify this error business. I'm gonna make one more video just on this error so that this video doesn't go too long. So if you're still interested in finding out this 2.4b, check out the next video. Thanks for joining us.